So, it's been a while. I think I like this format for these kinds of videos. So I need to try and figure out a process that allows me to publish videos a little more often. I've also been seeing your requests and I've been adding them to a list. So that's happening and hopefully I'll get to them when I can. As for today, I built a script that allows automation of the AWS cloud and the creation of a Windows ec2 instance. This is going to be more of a walkthrough of the code because I didn't capture it while I worked on it. So first up is just walking through the normal AWS cloud approach to creating an instance from an AMI image. I don't really know why they use that term. I think it's Amazon managed image or something. Anyway, so it's an image of a Windows box. You just create an EC2 instance of Windows, and then once you got it set up the way you want, you turn off the Windows box and then you right click on it and create image, and that creates this AMI image. But this is the normal approach to starting an image once you've created it. And this launches an EC2 instance. But let's say you want to automate this and just run a script and then shut it down. So that's the code I created. And most of this code I got from this website. It's actually a pretty good resource for programming AWS for Python. And the link will be in the description. But as you can see, this website has a lot of content. And if you just want something specific, you can just do a quick Control F and search for the term you want, like start or stop or terminate. And then you get the code associated with that term. So this Python script that I created allows you to automatically launch the AWS EC2 instance that I showed and then run any commands in that instance. It starts off with the packages you need to import. The big one is Bato3, which is the Amazon package that connects to the AWS cloud. This can be installed with pip install Bato3. And then you need the Winrm package, which allows for connection to the Windows client and can be installed using pip install py winrm, all one word. Well, the py winrm is one word. Next up are the needed Amazon objects to connect to AWS. There's a couple different ones, even though they all seem to be the same. One has a region, one doesn't have a region. Those are probably exactly the same, and then you have a resource versus a client. I don't know, it's kind of weird the way they're organizing it, but maybe it makes sense. But this gives you access to AWS and allows you to interact with the specific EC2 instances. And so we create the relevant objects for those. And these resources need credentials to connect to your AWS account. These credentials are stored on a folder in your user path as text files. And then back to the code. First we need this simple function to format the date time. This is for serialization with the AWS settings that we pass to the AWS cloud. It's just to format it so that AWS knows what it is. This function called command runs a local shell command, which the function called remote uses the command function to remote desktop into the Windows instance once it's created. The commented code stores the username and password on the first pass of running this function. And then I just comment it out because it's stored on the system, so you don't need it the second time. This username and password for the Windows instance of ec2. Then you have the function called launch, which creates and starts the ec2 instance on AWS. To create an instance this way, you have to have the ID of the AMI image for the Windows system that you want to launch. You can also set how many ec2 instances you want to create from this image through these settings. You can also supply the instance type, which is the hardware that this image is going to run on. I made that instance type a function parameter, so you can configure it however you want. Depending upon which script you run, you may need more processing power, so you may want to use a different hardware instance. You need the key name. This is the key to create the password for the Windows instance. So when AWS creates a new Windows instance, when it creates the username and password, it uses this key to generate the Windows password. But since I'm operating or creating an instance from an image, that image already has the password stored on it, and so I already have that password, so I don't need AWS to generate it, but I still have to give it this key. Tag option is to specify a name of the instance. So when you look at it in the list of instances on your cloud interface, you can quickly or easily identify which instance this is. I use the label, and then I just generate a random number at the end to create the name, so it's unique for the most part. I mean, it could still randomly create a identical name, but unlikely at the iteration that it's using. Then you define the network interface, which has a subnet that it belongs to, along with security groups. I have two security groups, one allowing the Winrm ports and the other allowing the remote desktop ports. This function called something is just the code I referenced to make this program. It was like a basic generic test code block, so it's not that important. Print response function. This function does the formatting of the string that's returned from Winrm. Winrm returns a binary response, which needs to be converted over to ASCII, or in this case UTF-8. Most text these days are UTF-8, and the Windows console supports UTF-8, so you may get UTF-8 characters. Well, at least in the world I live in. If you're using this in another country, you may only use UTF-8, but this will print out that string after it gets converted from binary. So this is just, the whole point of functions is to simplify repetitive code so you're not putting it all over the place. Then we get to the main function. First, this code gets the environment variables for the username and password. These are the credentials for the Windows client operating system, which have to be set before the script runs so it can get them. And these are in the environment, so this is the operating system that's running the script. So if you're on a Windows box, you'll need to set the environment variable there, and if you're on a Linux box, same thing. Taking this approach is a good security practice because you don't store your username and password in the script file, which then you subsequently store in GitHub, which then you make public, and then everybody knows your Windows password, username and password. You don't want that. So storing it this way in the Windows environment isolates it to the Windows account that is running the script, or Linux account that's running the script. So somebody has to break into that computer first to gain access, which is better security practice. Then it checks to make sure that the environment variables are set, and if they're not, it warns the user and then exits the program. You can supply the default instance type on the command line with the parameter, and it checks for it and assigns it. Otherwise, it uses the default instance, which is the free tier instance that Amazon recommends every time you create an instance. And then the script file that you want to run on the Windows client needs to be supplied, and this is designated by either -script or -s for the command line parameter. The code then checks to make sure that the script file exists and tells the user if it does not. Just basic checks, nothing too exciting. And then it prints the start of the execution with the instance type. This is for both debugging and telling you that it's doing something and to show progress. It gets a random number for the instance name, calls launch to create the Amazon instance. There needs to be a sleep step right here, because if you start calling Amazon for the instance, Amazon hasn't created it yet, and it'll just start throwing errors that cause your program to stop. So you got to wait a little bit for Amazon to create the instance, and then you can start querying the status of that instance. So on creating the instance, it actually creates an array. So one of the setting parameters is how many you want to create. So if you create more than one, you're going to have a bunch, which it's easier to store an array. But since I only need I'm only creating one and I only need that one, I just quickly pull the first element out of the array and then continue on. But I can configure this to support multiple instances if that's of interest, but I don't really need that functionality at this time. So if that's a feature you want to see, I can add it. But then it goes on and it prints the status of the instance, and it waits in a loop for Amazon to create that instance. Basically, is it starting up? Is it pending? Is it running? And of course, we're waiting for it to say running according to AWS. And once it has that, it moves on to trying to connect Winrm to the Windows client. So Winrm command throws an exception if it's unable to send the command to the client. So you create the connection and then you try and send the command to the client. And in this case, I'm just executing a basic hostname command. And if it can execute that command, it returns the results of that command. If it fails to connect, it throws an exception. So this is kind of some messy code just to test whether or not I can connect to the box. So it prints the exception every time it gets it, just to let you know that it's trying to connect. But once it does connect, well, it prints out the host, which is the command it was trying to execute. And then it prints out the time to show you how long it took to get to a point where it can start executing commands. This is so you can change the schedule time of your script to adjust for however long it takes Windows to boot up. But then it opens the script file, reads each line, converts it to a single line of execution. When it converts it to a single line of execution, it's appending an AND. That's what the AND symbol is for. And then also it removes any rem lines, which is basically a comment, and it removes empty lines so that it doesn't try to execute an empty line. The reason for single line execution is that the Winrm package resets the console every time you run a command. I spent a little time trying to see if I can create a permanent console that can change directories and set environment variables, etc. But every time you call the console command, it resets the environment back to the home folder and no environment variables, so that doesn't help. And so I also looked through the code to see if there was a direct function call that establishes a permanent console, which I didn't see one. So I'm either going to have to write my own or find another package that can do that. But for now, this works. I'm not running anything too complicated. So this Python code prints out the command that is being executed because debugging. One, you want to see that the command is formatted correctly, and then if anything else goes wrong, you can just copy that command and run it locally in the machine and see what errors might be happening. So running the command using this Winrm library returns a status code and then the output for the script along with the error messages, which then gets printed out. But this creates another issue. It would be better if the console streamed its output so you can print it out in real time. But this approach requires you to wait until it's done. So if it fails, you have no idea. If it's taking forever, you have no idea what it's doing. So it's not the best approach. But again, these are short scripts, so it's not too big of a deal. So once the script is done executing on the Windows client, the code stops the ec2 instance and then it terminates the ec2 instance. So minimizing the cost of running an AWS instance, because you're not having the human start the instance, try and run the script, wait for the script to run, and then fall asleep and then wake up and realize your instance is still running and then turn it off. This starts it, runs the script as soon as it's up, as soon as the script is done, terminates the instance, so minimizing the cost. So my script also prints out the time once it's done doing all of that, so you know how long it took to execute and how much money you just wasted on an AWS instance. So next is an example script file that you can create to run on your Windows client. It basically just executes the current path, then changes the path to the working directory, does a git pull to update the repo to make sure it has the latest files, and then it runs a simple Python script. That script then prints out the computer's hardware information. It's pretty basic, just for testing purposes. It's nothing too sophisticated. So you can create any script you want as long as it conforms to a Windows batch script file, at least in the basic sense. There's probably some limitations because I don't think you can execute something like a for loop in the shell or an if statement or stuff like that. So it's single line execution for the most part. I could probably change this to copy the batch file over to the Windows client and then execute that batch file. So then you can create more sophisticated and complex batch files. Or Winrm supports the PowerShell. So if that's an approach you want to take, you can convert this to run PowerShell executions. So version 2, I guess. If that's something you want to see, let me know. So other than saving money on AWS, how would we actually go about using this? One approach is Windows Task Scheduler. Another approach is Linux cron jobs. But in my case, I'm using Jenkins, which is basically similar to those, but it's more of a web interface approach. And so I can create a task in Jenkins that runs this script periodically. But the problem with Jenkins is that it requires an instance to be up and running and that instance to be registered with Jenkins. So instead of configuring a bunch of instances on AWS, because I don't know how many I need at a particular time, this script will create our instances dynamically. And also having a bunch of instances sitting on AWS costs you money. versus just one Windows image, which costs you a lot less money. So this Python script eliminates a lot of costs associated with AWS. So the example Jenkins task that I created to test this program runs the Python script on the Jenkins master node, which is the node that Jenkins itself is running on. But the script itself isn't really a computationally intensive process, so it's not a big deal to run it on the Jenkins master node. This task for Jenkins will need to copy Git or connect to GitHub and copy down the project, because that's where I stored the Python program at. So Jenkins task first deletes the working environment, because it's always good to start with a clean slate. You never know what kind of errors you get when you don't start off with a clean folder. And then it gets the script from GitHub. It sets the username and password as environment variables, as we discussed earlier. Then it shows you that the Python program was able to retrieve those variables. So then the script echoes the home path. This is the home path that Jenkins is executing from to know where the AWS credentials folder needs to be put. That's why I printed that out, but also just for debugging purposes. It then runs the Python program with the command line option for the script that it needs to execute. And then you get to see all the output of the Python program, running the commands for the Windows client, and then it finally deletes the workspace, because you don't want these files piling up on the local system. So specifically looking at the Python program's output, you can see that it first gets the GitHub for the AWS program. You can see that it starts the ec2 instance, tries to connect to Winrm, which it eventually does, and prints out the host name once connected. It also prints the time it took to connect, again so that you can adjust the delay for starting your task. Then it starts executing the script file and prints out the response from that execution, which the script itself is doing a git pull from the repo, and then there's new files. Then it runs the node Python script, which prints out the operating system, the CPUs, the amount of memory, and the amount of disk space. It then prints out the error message. This isn't really an error. Git prints this information through the error pipeline. I don't know why it does that, but people choose to print things weirdly. Then it terminates the ec2 instance. Well, it stops it and then terminates it. And then it's done. That's the whole execution path. So if you have any questions, let me know in the comments. If you found it to be useful, click the like button, I guess. Share it with your friends. If you didn't like this video, I don't know, tell me why. Leave a comment, tell me why. Or not. So, until the next video, thanks for watching.